Hi, I'm James McNeish. I'm one of the connections design managers for SSEN. I currently work in the Shetty region in the north, taking on our major demand connections and large generation connections. I was the one that had a strong part to play in creating the demand calculator that is available online, but also available for upon request to have a copy offline. We also worked with Scottish Power to develop a joint demand calculator. So today I'm going to introduce you to all of these and take you through. Back in 2019, we started work on how SSEN carry out our LV network studies because we want to make these more accurate and consistent across the whole of the networks business. This included reviewing and creating new domestic demand calculators as part of that process. We looked at to try and have a standardized approach towards the LV network modeling and create a system so that it was able to be consistent and throughout the whole process. In doing this, we looked at the domestic demands for each property so that we could look at the historic values and what could come up in the future. So for the calculator, we determined that the best approach for this was to make it match our network studies as well, because what we wanted to do is make it so that when you put in a request for a connection, that demand that you've requested is taken through not just from that request, it's taken it onto our network models and matches that exactly. And then what comes out at the back of that and the load that we see on the network models is the load that you've requested. So it takes it right the way through from quote through the design to your actual quote at the end of the day of what you actually receive. Yeah, in order to do this, we had to look at our historic data that have been used over the years and be used for many years. However, in doing this, we also realised as well that the way we use electricity 20 years ago is completely different to the way we use electricity today, and we have to start considering things like heat pumps. The fact we're less reliant on gas these days, so things like electric cooking, also electric vehicle charging. These are all add significant loads to domestic property, and especially to our distribution network. And all these things need to be considered when we're considering any demand calculator. We look to compare network results for existing knowledge as far as actually the gas central heated networks. And we also look to consider results for the electrically heated properties. And these sort of showed that they were roughly around about the correct sort of mark. We used ENAZ engineering recommendation P5 to decide if there's any relevant sections that could be used for our network as well. This included likes of looking at the heat pump profile that was in ENAZ P5, and we actually adopted that profile. We determined that heat pumps were being confused as far as actually the output heat is in kilowatts. The heat from the heat pumps is improving and is ever improving, so the efficiency is always improving. So it didn't seem right just to use a standard coefficient for a heat pump because not every heat pump's the same, and as it improves, that temperature coefficient will improve. So SSEN, as SSEN, we decided to adopt and use the input powers for the heat pumps and not to reduce this. This way, that meant we were using the input power and we were using input power per heat pump, which means our ADMD calculates it out based on the heat pump rating of the heat pump, rather than the output heat of the heat pump and using a temperature coefficient, which might not accurately reflect the input power of the heat pump. Sometimes that may be less, sometimes that may be more. There was a need to make sure, though, our network designs provided network results to ensure that the statutory limits are maintained as per SSE's policy and legislation that we've got to cover. And that's an important thing, that we need to make sure that we actually are compliant with our network and our models were compliant, so that was the basis around our designs. Looking at how we sort of were modeling the network and things, there's two main different design approaches that can be used. And these are detailed out in most documents. There's the ADMD method, which is the common method that people know and have knowledge of, because it's the after diversity and maximum demand. And there's the PQ method as well. So the traditional ADMD method establishes the expression to derive the maximum demand for a group of customers based on the average kilowatt per customer. The number of customers and the additional kilowatt for the loss of diversity associated with a small group. Whereas the PQ method approach derives a combination of demand of a group of customers by assuming demand will normally be distributed with a mean and variance. Predetermined design coefficients, P and Q values, are used to calculate the demand and voltage regulation based on statistical distribution. So SSEN's preference for this was to basically use the PQ method, and the reason for this is the modelling software that we use called WinDebut at the moment, that uses the PQ method in the background. Thus, we use the PQ method for calculating our demand calculator so that it matches our network models. So we've got to imagine that there are a few factors that will determine the load per property. And if we start to explore some of these, we've got the number of customers of that type. So for the customer type in the calculator, you're restricted to just selecting one customer type. That is one of the restrictions of SSEN's calculator. This means that you might have to complete a few to get the desired load that you're looking for, but it's quick and easy to change, which we'll demonstrate. However, the more customers that you do select on the calculator, to a point, will end up being less demand per plot to a point. Another factor that will affect it is the type of load. So the type of heating, such as heat pumps, electric boilers, gas heating, that's going to affect your demand. Number of bedrooms doesn't matter in this case, as far as that goes, because we are looking at the size of your heating rather than how many bedrooms. So if you've got a 4 kilowatt heat pump, input power for a heat pump, it'll be based on that. Whereas a larger house might need a 6 kilowatt heat pump, so it'll be based on that. Not all the loads actually matter to this, as not all the loads add to the diversified load. Now, part of the reason for that is we can't model every single load on the network. So there's things like electric showers. We know people have electric showers, but not every electric shower has a heating element as such. And that means that we can't really add that to our network models, so therefore we don't add that to our demand calculation. But that demand and those demands will add to the maximum demand to the property, and the calculator separates these two out to give you what the maximum demand of your property is and also the after diversity. Another factor that will affect the diversity is the profile used. So the profile will effectively be determined by the heating type, and for SSEN's calculator, there's three main types of profile that are used, but the calculator will select that based on your heating type. Now, one thing we've got to talk about as well is diversity, as far as how this sort of works and things. So diversity, basically for each property type, it'll basically create a logarithmic curve, which is shown on the right of the screen just now. And that curve basically will start to flatten out, as you can sort of see, around about 20 properties. So the example, say the example shown is actually for a 7 kilowatt EV charger for but for it'll be 7 kilowatts for a single EV charger. However, as you hit around about the 20 mark, it actually drops to around about 4 kilowatts, and that's the diversity that's applied to that type of EV charger. I believe that one is the commercial ones, but you can see it saturates it out, and that is pretty much standard across any of the profiles. So onto the calculator itself. The calculator itself asks you a number of questions. So the first question it asks you is about the number of properties, and you can select up to 20 on the web version. It then asks you a number of phases. Most commonly it'll be single phase, but you can select split or 3-phase there as well. The next one it'll ask you is the heating type, and you've got several different ones here. You've got electric, non-electric, heat pump, and electric boiler. If you, depending on what you select, may bring up further menus to input powers. So if we select heat pump, for instance, it brings you up the heat pump input power, and you're asked to input in kilowatts. It then also asks you about backup heating. The reason why it asks you about backup heating is previously a lot of heat pumps would be backed up with a boiler of some sort, or it could be some form of electric heating. So it asks you about the backup heating. If you select electric, it will ask you about electric. It then asks you, the next question is about electric cooker. Electric cookers don't add anything to the diversified demand, but if you select yes, it will add a value to the maximum demand. Last thing it asks you about there is electric showers. And it asks you if it's a yes or a no. If you answer yes, it will ask you how many showers, as far as that goes. So moving down, you've also got the other significant loads. Other significant loads. Now this is anything that doesn't connect into a 13 amp socket. You've got the choice to answer yes, no, or maybe. If you answer yes, it will ask you about the input power for that and things. We're only really interested in anything above the 4 kilowatt sort of mark, and I think this only adds anything into the power if it's above the 5 kilowatt. But if you select yes, you would have to enter there. The final question it asks you is about EV chargers, and if there's any EV charging points. This is a yes or no sort of question. If there is EV charging points for the domestic connection, it will ask you about the number of EV chargers for that connection type, and also the input kilowatt power. So that's basically our web version as far as that goes. There's also at the bottom of the page, you can see the calculate button, and there's also a reset button. So if you get to that stage and you think you've made a mistake, you can also hit reset. So if we take you through an example just now, you've got, if we take this example of 10 properties with single phase required, with a heat pump, input power of 3.5, no backup electric heating, with electric cooker, no showers, and no EV chargers. And we can hit calculate, and that'll produce us a set of results. So the results that we've got here, the first part is a nice summary, and it gives you a nice summary of all the results of everything that you entered as far as that goes. So if you've made a mistake, you can very easily see that and things. So moving on to the results itself, the first part is the maximum demand load per customer in kVA, and also then in amps. If this was for a single phase and maximum demand above 100 amps, a warning would actually be displayed that split of 3-phase may be required. This does not mean that it's actually required. It's just a consideration for you to sort of consider. Other options may be available, such as load limiters and things that can limit the load below the 100 amps. But it gives a total maximum demand for all the properties, which is basically the bit that we're more interested in, because that's the load that we would see on our potential on our network and things. But when you compare this to the diversified load, which is basically the load that we would actually see on the network for 10 customers, you can see it's a lot less. So in this case, the maximum demand for the site is 87.5, whereas the diversified load is 44 kVA. So this would actually give a demand after diversity per plot of 4.4 kVA. As far as that goes. Now down the bottom, you've got two options as far as things goes. You can hit the reset and reset everything back to the start and have to enter everything again. But say you've got, for example, some more properties, but they've actually got then EV chargers. You can actually just hit back, to the non-electric. Sorry, we can then just use back and actually make an edit and add in the EV chargers or make changes if we need to make changes. So in this case, if we hit back, we can go back and we can make a change here to actually adding in this to be non-electrically heated instead, and we can add in the EV charger with one EV charger and it being 7 kilowatts and hit calculate and get results again. The results this time would give you a maximum demand of 122.5 kVA, whereas diversified load is 56 kVA. So basically the diversity after demand after diversity would be 5.6 kVA per plot. Unfortunately, currently our online version restricts us to 20 properties, although we are looking to extend that. However, there are two options available to you to sort of get a greater demand than 20 at the moment. SSEN's own current version is available upon request, but does not restrict you to the number of properties. So an example looking at for the same site, but say for 100 properties and then 50 properties, we can look at the Excel sheet. The Excel sheet's simple to use. Has several tabs at the bottom, but the one that we will use is the demand calculator and the customer load estimator. You basically fill in the parts on the left that are highlighted green. You want to try and fill in them all. It will still give results, unfortunately, if you haven't filled them all in, but you can very easily fill them in. There's also print and clear data buttons on the right hand side, so you can quickly save things to PDF if you wanted to. You can avoid resetting, for example, if half the site has EV chargers and the other half would run this twice, but for half we'd remove the EV chargers and half we wouldn't have the EV chargers, which is what I'm currently doing in the example that I'm showing here. So you can add these values to get a diversity load of 300 once you sort of get there. So basically, I think the first value we get was 229 kVA with EV chargers and 71 kVA without. So that would give an overall diversified load, if you add them together, of 300 kVA. Likewise, if you wanted to see the impact that EV chargers had on your site, you could increase the number of customers to 100 and get 138. Shortly after developing the calculator, through a house builder, we were actually encouraged to sort of work with Spen to see if we could come up with a standardised approach. Although we didn't arrive quite at the same conclusions, we realised that we're pretty much aligned above 20 properties, and it became clear that we could have an option for having more than 20 properties. Below 20 properties, however, this was going to take a lot more work to get anywhere close to being sort of more aligned. And for ourselves, it would have meant changing how we do our network models, because we felt that that was important, that it went through from initial design stage right the way through our network models and then out the other end to your quote. So the approach we sort of took was to combine SPEN's calculator with SCCN's calculator to see which one came up with the worst results, as far as that goes, and make a calculator that combined the two that provided the worst results from the two different calculators. This actually provided a bit of a 50-50 split, where sometimes it was SCCN that was slightly worse, and sometimes it was SPEN that was slightly worse. And neither of us were in one way or the other way. So using this for above 20 properties means that even if you apply to SCCN or to SPEN, the demand should effectively be the same, or it'll be very, very close to being the same. So this is simple to use and uses the worst case from both SCCN and SPEN's calculator. So if we look at the development we were looking at before in SCCN's calculator, we can look at the development that was for 100 properties, with 50 having EV chargers and 50 not having EV chargers. And in this case, the calculator comes out and gives us a calculation of 307.5 kVA property, which is almost slightly higher than SCCN's calculation of 300 kVA. So, it is straightforward to use. Just ask a series of questions at the top as far as different variables. And in the case we're looking there, initially how many had EV chargers. You can use it to have EV chargers and heat pumps and any combination sort of in between. So for a house and estate with 50 heat pumps only properties and 50 with both heat pumps and EV chargers, with 50% being air source heat pumps and 50% being hybrid. This would give a standard ADMD of 425 kVA and a cold start of 642 kVA. If you go onto the assumptions tab, there are some assumptions that are made which can be found here, such as the EV charges are assumed to be 7.36 plus the value of the heat pump compared to the heat pump value in kilowatts. There's also a guide to assist with its use on the next tab, but the calculator is restricted to being used between 20 and 100 properties here. We wouldn't recommend you to use it for less than that, and if you're using it for more than 100 properties, then this will effectively go into several substations, so the ADMD kind of doesn't matter at that stage. So like anything, you've given a short introduction to the calculator and things, and we've got to talk about advantages, but we've also, before we talk about them, we've got to talk about some of the disadvantages of the calculators and things. So some of the disadvantages of SCCN's own calculators that's available online is that it can only be used for one customer type at a time. And unfortunately, that's the logic behind the scenes, and it would become way, way too complicated to allow more than one customer type. And it's not impossible to sort of do, but it would require a lot of work and be very, very technical to sort of try and resolve that to get an accurate figure. So we determined that actually it's easier just to add, quickly do a second calculation or however many you sort of need for that customer type and add that in. The website one also restricts you down to just using it above 20 to below 20 properties, but we are looking to expand this, and this was sort of brought across from historical calculators, but that's something we're looking to hopefully expand in the future. One thing we've got to say is the demand calculator is only for domestic use. It's not one for commercial use, such as shops, gyms. And the reason for that, the reason why we don't have a ADMD calculator for that, is the use of commercial properties is so varied. I've just highlighted a few there: a shop, a gym. You could have pubs, all sorts of different things as far as things goes. So there's such a variance there that we just simply couldn't provide an ADMD calculation for a commercial property. We would always recommend getting in touch with the electrician to see exactly what they require. So moving on to some of the advantages of using the calculator. Um, you know, we use this. Basically one of the main advantages is we use the same uh, load applied to the network model through the design to producing the quote. This ensures that we meet SSCN's statutory requirements and we design a safe, reliable network for our customers. It means that the network reinforcements are not costed where they're not actually required. We have historic requests where people come in and ask for 23 kVA for a single phase house, where this could have actually been a lot less. And potentially down, instead of being studied at 23 kVA, it could have been studied at 2.25 kVA, which is significantly different. The tool online is quick and easy to use and quick and easy to make changes. And even the Excel formats are fairly quick and easy to use once you're used to using them. So we've got to look at where you can sort of find these. So below the 20 can be found on SSCN's website under the Tools and Maps section. And then if you scroll down to the demand calculator, you can find it in there, and that's where you find the SSCN's online version. Scottish Power's version, if you go on to Scottish Power's website and go on to the Getting Connected part, and then the left-hand side under that menu, there's the ADMD calculator for LCT ready housing developments above between 20 and 100, and then you can download that one from there. The third option, SSCN's version internally that can be shared to yourself. It's not restricted to the number of properties. You can add as many as you want if a single customer type. The Excel can be shared with you upon request, but it can't be found on our website. That's just due to the fact that we've got macros enabled in the workbook and we can't upload that, unfortunately. So we've very much talked about what we currently have and the calculator that we currently have. So if we look at the future now and what could happen in the future and things. So technology is constantly evolving and developing. Going back 5-6 years ago, maybe even 10 years ago, heat pumps were very rarely installed onto the network. They're pretty much getting installed all the time, exactly the same with the EV chargers. So that means we have to rapidly sort of moving things. And if these are all getting connected retrospectively, they do potentially cause issues on the network because our model and everything assumes everything's balanced. In reality, they could go into onto the same phase and then cause issues on our network as well. So as part of our ED2 plans, we are actually installing LV monitoring to try and get better understanding of our LV networks, so we can reflect this back into our network models to create more accurate studies, to create a better, more safer, reliant network. There's also a lot of work being done around the network modeling to try and help make this quicker and easier, so that we can get properties connected quicker, easier, and when you require them. There's also new technologies that's emerging and being developed, such as load limiters, as far as they're being used in EV chargers more and more. There's also innovation projects that will help provide evidence to help change the approach and hopefully reduce some of these values in the future. We do know that IDNOs and other DNOs use different calculators, and this does frustrate developers. We can only apologise for that. However, for an IDNO, they would still have to come to the DNO for the supply. An SSCN in our area for a load that they will study for a load that they request. Likewise, other DNOs will follow their policy. So if an IDNO decides to use smaller figures in this, they'll be coming to us for a smaller demand for their site, and we'll model our network and design based on what they provided us. We've already seen as well that we try to align as best as we could with Scottish Power, and it's very, very difficult just to get DNOs to agree on things. Especially in something like this where there's not a standard way of doing things. So there's not that standard approach. So what's SSAN done? You know, in summary, sort of what SSAN have done is we've looked at our network studies and our policies for this. We've looked at how we're doing the studies, and what we've done is we've created a calculator to form part of this, so that it matches our network models and matches the quote that you'll get at the end, as far as that goes. But we'll always continue to look to evolve. We'll always look to continue to develop, and we're looking at the technology changes to see what we can do for the future as well.